Hey everyone, and welcome to The Explainer. Today we're talking about something absolutely wild, a phenomenon that literally shapes every single aspect of our modern lives, but is totally invisible to the naked eye. Okay, let's dive into this. We're going to explore the core principles of magnetism, those hidden microscopic structures known as magnetic domains, and how all this interacts with electric currents to basically build the world as we know it.
I want you to think about this for a second. What invisible force is actually powering our modern technology? Seriously, think about it. When you flip a light switch, when you drive a car, or even when you're just sending a quick text on your phone, there is this fundamental physical relationship working behind the scenes. It's incredibly easy to take for granted, mostly because we can't physically hold it in our hands, right? But understanding this force, that is absolutely crucial. It's the key to understanding how our entire technological infrastructure actually operates.
So, Section 1, the mystery of magnetism. To really wrap our heads around this, we're going to use a zoom-in, zoom-out framework.
Starting with the basics, we kind of need to stop looking at magnetism like it's just magic. And I get it, it totally feels magical when you hold two magnets and they push apart seemingly out of nowhere. But magnetism is actually a defined, highly structured physical property. Our first goal here is to just unpack that. It's a very real, tangible force of nature that dictates exactly how specific materials interact, whether they pull together or push apart, all based on these invisible fields of influence.
Moving right along to Section 2, Inside Magnetic Domains. We're zooming all the way in past the surface now to look at these microscopic structures.
Let's take a beat here, because this part is super foundational. To understand where this structured field comes from, we use models to make the invisible, visible. Imagine magnetic domains as these incredibly tiny microscopic pockets inside a material. And inside every single one of these pockets, the atoms are acting like little grouped compasses or tiny directional arrows. In certain materials, like iron, these atoms naturally bunch up, and within that one group, all their little compass needles point in the exact same direction. So just picture that, a microscopic landscape made up of millions of tiny, localized directional arrows.
And this brilliantly illustrates exactly how that model dictates whether a material acts like a magnet or not. On the left side, when those magnetic domains are randomized, you just have chaos. One tiny compass points up, the guy next to it points down, another points left. They're completely canceling each other out. The material has domains, sure, but there's zero overall magnetic field. It's completely unmagnetized. But on the right side, when a material is magnetized, all those tiny grouped compasses are perfectly aligned. They are all pointing the exact same way. Suddenly, instead of chaos, you get this unified, powerful, structured force. The relationship is super clear. Alignment of those domains literally equals a measurable magnetic field.
All right, Section 3, magnetism meets electric currents. Now that we've seen how domains work at the micro level, it's time to zoom back out.
Let's move to and see how this builds into an absolutely wild cause and effect relationship. Step 1, you take those structured magnetic fields we just talked about and introduce them to something conductive, like copper wire. They interact. Step 2, that active relationship actually generates electric currents. Literally, if you move a magnet through a coil of wire, you induce a flow of electricity. But wait, it doesn't stop there. Step 3 shows that the reverse is perfectly true too. Flowing electric currents can actually create their own magnetic fields. It's this continuous reciprocal dance. Electricity creates magnetism, and magnetism creates electricity. Which brings us to Section 4, Powering Modern Technology. This is where it all comes together. So, why does this invisible dance actually matter to us? Well, because understanding this link is definitely not just some abstract academic exercise. It is the literal blueprint for our modern civilization. By continuously evaluating, communicating, and manipulating these specific forces, scientists, engineers are out there solving massive, real-world challenges every single day.
I mean, just look at how completely dependent our current technology is on this relationship. Think about power grids generating electricity for whole cities. How do they do it? They rely on massive generators that spin giant magnets inside huge coils of wire, basically scaling up that exact same relationship we just looked at to a massive degree. What about the motors driving modern vehicles, from electric cars to industrial machinery? They use electric currents to create magnetic fields that push against other magnets, turning electrical energy straight into physical motion. And zooming way back down to the micro level, the components inside your phone or laptop use tiny electromagnetic fields to process and transmit the data that keeps us all connected. All of it, the power, the motion, the communication, the whole shebang, stems directly from those aligned domains and electric currents.
Which leaves us with this final thought for today. We've clearly mastered the basics of utilizing magnets for our current needs. But as our tech gets smaller, faster, and infinitely more complex, how will future technology continue to harness this invisible relationship? The core physics won't change, but our models and our innovations for sure will. Thanks so much for joining me for this explainer. Keep asking those big questions, and I hope this helped make the invisible forces all around us just a little bit more visible.